Just go on page 108 when we're done. So it says, like other functions, trigonometric functions can be translated. Given the functions to the left that are written out over here, C represents a what kind of shift? Horizontal. Okay. And D represents, oh goodness, D represents a what? Vertical shift. So as we know from every other transformation that we have done before, plus D shifts up, minus D shifts down, plus C shifts what? Down. That's okay, it's C, left. And they're called, the horizontal shifts are called phase shifts for trig functions. And minus C goes right, because remember that X lies. So that should be no-brainer. We've been doing transformations for a long time. Hopefully we get this. So real quickly, we're just going to describe these. So on number 1 here, cosine of x plus 2, what kind of translation happens here? Up 2. So we're going up 2. In number 2 right here, tangent of x minus 1, we're going down 1. Right. Sine of quantity x plus pi halves, we're going where? Left. How much? Pi halves. Because remember your x-axis has pi's on it because they're the radian measures. And then for number 4, we're going to the right pi. Okay. Everybody good with that? So when we're graphing these, there's a whole lot of patterns, right? We're basing a lot of stuff off of our intercepts and with that x-axis. But then when we shift things up, we lose that x-axis there. But just like when we shifted other graphs that have asymptotes, the asymptotes just shifted right along with it. So although there's no asymptote for sine and cosine, we do have this kind of imaginary x-axis that can follow it because there's symmetry there. So it says shifting a graph vertically will create a new horizontal axis called the midline. Okay, the midline. M-I-D-L-I-N-E, because my word got squished in there. This is the reference line to which a graph oscillates. This is an oscillating type of thing. So if you look over here, we have, this is sine of x. This is sine of x plus 4. So it just got shifted up 4. So what would the equation for the midline be? Y equals 2. Y equals 4, right? 1, 2, 3, 4, y equals 4. So just like because right now, that midline, we have a midline here too, we just didn't talk about it because it's the axis. So right now, that's y equals 0. Since I shifted up 4, now it's y equals 4. So the equation of the midline is just y equals d, whatever that is. And even though it is not an asymptote and it doesn't have to be graphed, best you graph it because it's going to help you get everything else in there, okay? Any questions at this point? Stop. Ask me questions if you have them. Don't let me go all the way past something and then you be confused. It says graph the function, then identify the characteristic of the graph here. So let's here. What's the amplitude? 3 halves. And what is the period? 2 pi, because it doesn't change, right? Do we have phase shift here? The phase shift is none. The vertical shift I do go up 3, which is the midline is y equals 3. So this is a line graph. So I'm going to draw in my little parent function. Do you draw parent functions every single time? Not. I think if you're all right, so, and I'm also going to draw in the midline. It's at y equals 3, so I'm going to put it in lightly, like a dotted line, kind of like an asymptote, but maybe even lighter than that, just because it's not really part of the graph. But it's also fine not to erase it at the end, okay? Start at 0, 0 for the sign. But my new 0, 0 is line. Amplitude does not change that point. And I have no phase shift, so my point is right there. Just think about the midline as your new x-axis. That's 0, 0, and you go from there. The other thing that I've been asking people period and the end of the period first. The period ends at 2 pi. So from this point, there's the end of the period. Then I get the middle at this point. Then halfway between intercepts, there's no reflection, so I know it's going to be a maximum. The amplitude is 3/2, so it's 1.5 up from the midline, and it's right there. Then it's halfway in between these two and 1.5 down. Everybody okay with that? And then from there, those are 5 good points. Then you want to repeat them. You can do it in whatever manner you want, but again, I would be kind of consistent in what you're doing. I would do all the intercepts first, so then I could go back and alternate. Otherwise, I don't think I'd get everything in the right spot. And I still may not, but it should look like this. Ask me questions if you've got them. Are we good? Okay. Let's look at number 6 then. What's the amplitude in number 6? Does tangent have one, first of all? No, so it's undefined, but I still have a number that's important to me, right? Where and there is no vertical stretch or compression, but 1 is that number that I got to use. So I'll write it down so I know I don't do anything weird. What's the period here? Okay, the period for the parent function is pi, right? Is there a b in here that affects this? No, so it is still just pi. I have a phase shift, and I'm going to the left pi halves, right? There is no vertical shift. So my midline then is at y equals 0, which is, I mean, we had one yesterday, or, you know, when we first, but we didn't talk about it. It doesn't even matter. It's the axis, so I definitely don't have to draw that one in. This is tangent. So my parent function looks like this, right? I'm going to do the beginning and the end of the period. So tangent starts at 0, 0, and so my midline is at 0, so I can start here. But I have a horizontal shift to the left pi halves. So this is now this new point. You have 2 options to get the end of the period. You could find where the end of the period would be and then shift it, or you know where it starts. You know the length is pi. So if this is at pi halves, here's pi halves, another pi halves. This is now the beginning and the end, and that distance right there is pi. Once you get the beginning and the end, everything else is half, half, half. Okay? Everybody good with those 2 points? So then I have an asymptote in the middle of this. Halfway in between the first intercept and the asymptote is a positive, and it's going to be 1 because there is no stretch. Halfway in between these two, it's a negative 1. So now that I have that, then I can just repeat my pattern. Okay, I have this intercept, so then I'm going to have a point here, and then I have asymptotes at every pi because that is the length of the period. And I can get all those points in there. Oops, this one. And some of you need to learn to graph a little quicker. I do not want it to look like your pencil threw up on your paper, but it also does not have to be like the most perfect, accurate graph in the world. And I know I'm talking to some perfectionists here, and you're like, yeah, right, whatever. But I'm just saying that, you know, you got to think about time sometimes. All right, any questions at all at this point? Because it's about to get a little wackier. Okay. And if I don't give you time to finish the graph, because either, and it's not always because you're trying to be a perfectionist, you could have done it wrong, so you erased it, now you haven't had time to finish it. Get part of it done so it makes sense, and you could go back and finish it later, and then move on with me instead of staying there and not hearing the next part.
Because there is like another point on each side of it.
Oh, there sure is. Yeah. I'm sorry, I missed that. Dang it, I did that the other day too. Yes, so it's there. Yes, thank you. You should graph the ends. Good question. All right. All right, so number 7. What is the amplitude? 4. What is the period? 3 pi. Is everybody okay with that? Because I'm taking 2 pi and dividing it by 2/3. That's where that 3 pi is coming from. So make sure you understand where these numbers are coming from. If you don't, make sure you ask. I have a phase shift, and I'm going to the right pi. The vertical shift of up 1, so midline is y equals 1. Everybody good? Okay. This is cosine, so my parent function looks something like this. Now, this one is going to be one of the ones where you're going to have some options on how you're going to have to handle it, because it's going to be hard. It's going to be impossible to get these 5 points that I really want on there. Okay, and I'm going to give you some options on this, so you got to make sure that some part of this actually makes sense to you. And then I'm going to draw in my midline or sketch. Oops, I'm going to do that in lighter though. Draw and sketch in my midline. And so the way I would start is just pretend like the midline is the x-axis. When you do that, these two things right here are automatically taken care of. Okay, you just change what your x-axis is. So for cosine, your parent function starts here at 0, 1. Okay, well here is 0, 0. It's 1 because the amplitude's 1 in the parent function, but the amplitude's 4 here. So from my new x-axis, I go up 1, 2, 3, 4. Oh, wait, but I don't make a point there yet, sorry. So I've taken care of the vertical shift. My amplitude is 4. I have a phase shift to the right pi. So I have to go to the right pi, and I make my point. Okay? So one more time. This is my new 0, 0. Amplitude is 4, so from here, I have to go up 4. Then I have to have a phase shift of pi, so I move over pi. Okay? Everybody with me where that point came from? Now, the end of my period is at 3 pi, or the period is 3 pi long. So since I shifted over pi, it's way out here at 4 pi. I have no chance of graphing that, right? So instead, I can think about things this way. I'm starting at, that point right there is actually now at pi, yes? If the period is 3 pi long, then this would end at 4 pi. You all agree with that? What's halfway in between pi and 4 pi? Is it 2 pi? It's 3 pi halves, actually. Okay. The other way you could think about it is starting at 0 and making this 3 pi. And then this is 3, actually it's not 3 pi halves. What is it? It's 5 pi halves. Okay, let's back up. We're going to do it a different way because I think that's confusing for everybody. That's not how I did it last period. Makes more sense this way. We're going to think about it before the shift. This is why I told you it's better to use cosine this way instead of making it look like sine, because when you start doing the shifts and stuff, it can get very confusing. So let's think before the phase shift, because I wrote down the wrong thing and now I think I'm going to confuse you. So for my parent function, if the only thing from the parent function that changed was the period, this would be 0, this would be 3 pi. Do we agree with that? Okay. In between those two, see, it's much easier to do that this way. This is 3 pi halves, yes? So here's 3 pi halves right here. I'm not plotting anything here. But I still have to shift to the right pi. If I do, I'm still off my graph. That was kind of the point I was trying to make. So even this point here, I can't graph. I can't graph this one either. But halfway in between these two is this point right here, yes? So what's halfway between 0 and 3 pi halves? 3 pi fourths, right? Okay, now don't plot anything at 3 pi fourths. But if I'm at 3 pi fourths right here, I still have to do a phase shift of pi. So if I move to the right pi, I end up here, right? But I have to be on, this is my new x-axis, there's this point right here. So I'm only able to put these 2 points on there from my parent function. But that's okay, because everything is so symmetric and repetitive, we can get everything else on there. This graph continues, right? So it looks like this, but doesn't it do this, right? So if I have these two done, well, this one is going to be an intercept, and it's the same, these two distances are the same, right? So if I have to go 1, 2, 3 to get to this point, then I go 1, 2, 3 on the other side. There's my other intercept. Then I should be able to find the x value for the minimum. I'm going to go to the left 1, 2, 3 again, and then from my midline, my amplitude is 4. I go down 1, 2, 3, 4. You just have to make sure you are using the midline and not the axis. Okay, that's why it needs to be drawn in. Then we go to the left, 1, 2, 3, and I'm back up here. Go to left, 1, 2, 3, and then I go up 4, and I have that point there. The ones that get the most complicated are the ones where it does that you can't fit this stuff on the x-axis. And I think that's where, or you can't fit this stuff on the graph. And I think that that's where most people were having their confusion anyway. Okay, everybody okay with that? Ask me questions if I lost you somewhere. We good? Okay. All right, so we're going to do 2 more together, and then you're going to do 2, because I feel like we kind of need to do 2 more. Let's do this tangent. All right, so what is the amplitude here? Yeah, it's undefined, but then it's that 1 is my important number. There's the vertical stretch compression. It's not even there. What's the period? Pi halves, because remember, for tangent, the parent function period is pi, not 2 pi. So this period ends up being pi halves. I have a phase shift to the left, pi fourths. And I'm going down 3, so y equals -3. So the good news is with the smaller periods, you can fit more of the stuff on there and it doesn't get quite as weird. It just gets squished sometimes. Okay. And my midline is at -3. So remember our midline, if we just use that as our new x-axis and pretend like the other one doesn't exist, then we've taken care of our vertical shift altogether. Tangent starts at 0, 0. So this is my new 0, 0. That's taking care of the vertical shift. I have a phase shift. I have to go to the left, pi fourths. So this is pi fourths right here, and that's my point. So that's this one. I now want this one, which will also be on that midline. The distance between these two is the period. The period is pi halves. Each space is pi fourths, so I go 2 of them, there's pi halves. There's the beginning and the end of the period. Then half, half, half. Halfway in between that is an asymptote. Halfway in between the first intercept and the asymptote is going to be my amplitude that isn't really an amplitude, right? And it goes up +1 because there's no reflection. And then between these two, it's a -1. There are your 5 pieces. It's pretty squished, okay? You're going to have an asymptote every other one and an intercept on that midline every other one. So for me, I always draw in the asymptotes and these intercepts first. That way I can more likely alternate them correctly. Still doesn't guarantee I won't mess something up, but... Okay, and I know not all of you graph as fast as I do, and that's okay. I want you to get... Do what? What? Oh. That's right. Okay. These are smaller. Okay. Yeah, okay. Somebody asked me that last period. They said, do I have to make them go all the way? Okay, you don't, but I also don't want you to be like, once you get to that point and then there's like an arrow right there. Like it needs to go at least a little bit past that point so you see what's happening, but yeah, that's fine. So even if you didn't finish this yet, make sure you have some of it done so that you understand the idea and that you don't have any questions. Then move on with me so you're not missing anything, and then you can come back and finish it, okay? Because I know, especially if you end up having to erase, you're behind the game and it's fine, okay? Any questions? All right, let's do 9, and then I'm going to have you do the last ones. What is the amplitude in 9? 3. The period is pi over 2. Okay, good. Do I have a phase shift? Right pi halves. Oh, that doesn't even look like a right. Right pi halves. Oh my goodness, come on. Come on, what the heck? All right, well, whatever, it doesn't want me to erase. I can't erase that, so right pi halves. Vertical, I'm going down 2, so y equals -2. All right, so this is sine. Looks like this. And, oh, my midline is at -2. Okay, so sine starts at 0, 0. Because of the midline, this is my new 0, 0. The amplitude does not affect 0, 0, but I have a phase shift of pi halves, so I move to the right pi halves. I want the end point of the period. The period is pi halves long. So I go pi halves from that point, which would be right there. There's the end of the period. Then half, half, half. Halfway in between those two is that third intercept right here. This one's really skinny too. Halfway in between these two, there's no reflection, so it will be a maximum. That maximum is determined by my amplitude, and I'm counting from the midline. So halfway in between here, I go up 1, 2, 3. Halfway in between these two, I go down 1, 2, 3. There are my 5 anchor points. There's going to be a lot of points on here. The next thing I would do is go plot all the other points on my midline, which means there's one at every single space. And you can just go back and alternate. And your hand won't fall off, I promise. I have more pencils in the back if your pencil runs out of lead. All the other complaints. Okay, I think we're good. Yes? All right. Okay, so let's, on 10 and 11, I just want to talk you through the stuff on the right so I can make sure everybody's starting at the right place, and then I'm going to let you graph them. I'll go ahead and hand out the assignment while you're doing that, but I want to check both of these for you, and I'll come around and help you with any questions that you have on any of them. So let's look at 10 first. Our amplitude is what? 1. Period is pi. Phase shift is left, 3 pi fourths, good. Vertical shift is up 4, so this is y equals 4. All right, any questions about any of that stuff? Right, so then let's just do 11. Our amplitude is undefined, but do we have an important number here? Yes, that 2 is your vertical stretch that is going to play a part. What's the period here? 2 pi, because I have to take pi and divide it by 1/2, so it's 2 pi. The phase shift, I go to the left, pi, go up 1, and my midline is y equals 1. Okay. Any questions at all? All right, so get both of those graphed. I can come around and check them one at a time for you and help you if you're getting stuck. I want you to try and get those done on your own. Okay, so I'm going to talk you through graphing 10 and 11. So on 10, this is a cosine graph. So it's going to look like that for my parent function. And my midline is at y equals 4 up here. Okay, so I'm going to start with this point. Okay, my amplitude is 1. So on the y-axis, remember my midline is like my new x-axis. My amplitude is 1, so I go up 1. But then I have a phase shift. I'm supposed to go to the left 3 pi fourths. Here is 3 pi fourths. Okay, because this is pi halves, so pi fourths. Every step is pi fourths. The period is pi. So from the beginning to the end of one cycle is pi. So that's 4 pi fourths. So 1, 2, 3, 4 pi fourths is pi. Now I have these two. Now that I have the beginning and end of my cycle, everything is half, half, half. So halfway in between these two x values is the x value for my minimum point. Here's my midline, and I go down 1 because the amplitude is 1. That's this point. Halfway in between is an intercept on the midline, and there. So now I have those 5 points that I can repeat. I can see that my intercepts are on every other x mark. And then these alternate up and down. And here we go. Okay, that is what that one should look like. For number 11, my tangent parent function looks like this. My midline is at y equals 1. So I'm here. Okay, so tangent starts at 0, 0. So because of the midline, this is my new 0, 0. And I have a phase shift. I have to go to the left pi. So I end up right here. The period is 2 pi. So this is my first point. My second point is pi away. So if I'm here at negative pi, I need to go to the right. Oh, I'm not sure what I just said. From here to here, it needs to be 2 pi because that's the period. So here's 1 pi, 2 pi. They're the beginning and the end of the period. Then I draw in my asymptote halfway in between. So I've got that. Halfway in between the intercept and the asymptote, I'm going to have this point, which for the parent function is at 1, but I have a vertical stretch of 2. So halfway in between here, I go 2 up from the midline. And between here, I go 2 down from the midline. Make sure you're using the midline and not the axis. It's very easy to use the wrong thing there. So then from that, got my 5 anchor pieces that I need, and I should be able to replicate the rest of it. This is going to come up here. And then I'm going to have asymptote. This will be over here. Oops, wrong one. Here. And then I have an asymptote. And this one looks like this. There you go. Be very consistent in what you do in the graph. Do the beginning and the end and then the middle, and you'll be able to get your graphs done a whole lot more accurately.